Hi everyone, welcome to this chapter TCP Overview. In the first point is TCP Features. In the previous topic, you learned that TCP and UDP are two transport layer protocols. This topic gives more detail about what TCP does and when it's a good idea to use it instead of UDP. To understand the difference between TCP and UDP, it's important to understand how each protocol implements specific reliability features and how each protocol tracks conversations. In addition to supporting the basic functions of data segmentation and reassembly, TCP also provides the following service. Establish a session. TCP is a connection-oriented protocol that negotiate and establish a permanent connection or session between source and destination device prior to forwarding any traffic. Through session establishment, the device negotiates the amount of traffic that can be forwarded at a given time, and the communication data between the two can be closely managed. Ensure reliability delivery. For many reasons, it's important for a segment to become corrupted or lost completely. As it's transmitted over the network, TCP ensures that each segment that is sent by the source arrives at the destination. The next step is provide same order delivery, because network may provide multiple routers or router that can have different transmission rates. Data can arrive in the wrong order. By numbering and sequence the segment, TCP ensures segments are reassembled into a proper order. And the last step is support flow control. Network hosts have limited resource, memory, and processing power. When TCP is aware that these resources are overtaxed, it can request that the sending application reduce the rate of the data flow. This is done by TCP regulating the amount of data the source transmission. Flow control can prevent the need for retransmission of the data when the resources of the receiving host are overwhelmed. For more information on TCP, search the internet for the request for comments RFC 793. The next point is TCP header. TCP is a stateful protocol, which means it keeps track of the state of the communication session. To track the state of the session, TCP records which information it has sent and which information has been acknowledged. The stateful session begins with the session establishment and ends with the session termination. A TCP segment at 20 bytes, 160 bits, or overhead when encapsulating the application layer data. The figure shows the fields in a TCP header. We can see source port, destination port, sequence number, acknowledgement number, header length, reserver, control bits, window, checksum, urgent, option, and application layer data size varies. TCP Header Fields. The table identifies and describes the 10 fields in a TCP header. Source port, a 16-bit field used to identify the source application by port number. Destination port, a 16 bits field used to identify the destination application by port number. Sequence number, a 32-bit field used for data reassembly purpose. Acknowledgement number, a 32-bit field used to indicate that data has been received and the next byte expected from the source. The next is header length, a 4-bit field known as data offset that identifies the length of the TCP segment header. Reserve, a 6-bit field that is reserved for future use. Control bits, a 6-bit field that include bit code or flag which indicate the purpose and functions on the TCP segment. Window size, a 16-bit field used to indicate the number of bits that can be accepted at one time. Checksum, a 16-field bit used for error checking or the segment header and data. Urgent, a 16-field used to indicate if the contained data is urgent. Applications that use TCP. TCP is a good example of how different types layer of TCP IP protocol suite have specific roles. TCP handle all tasks associated with dividing the data stream into segments, providing reliability, controlling data flow, and reordering segments. TCP frees the application from having to manage any of these tasks. Applications like those shown in the figure can simply send the data stream to the transport layer and use the service of TCP. And this is the IP layer. The next step is TCP, and the next is the application layer. How is HTTP, FTP, SMTP, and security shell? Check your understanding which transport layer protocol ensure reliable same order delivery, that is TCP. Which TCP header statement is true? It consists of four fields in a 8-bit header? No. It consists of 8 fields? No. Okay. Okay. TCP header consists of 10 fields in a 20-byte header. Which two applications will use the TCP transport layer protocol? Choose to HTTP and find file transfer protocol. I don't know. Okay. The next point is UDP overview, UDP features. This topic will cover UDP, what it does, and when it's a good idea to use it instead of TCP. UDP is a best effort transport protocol. UDP is a lightweight transport protocol that offers the same data segmentation and reassembly as TCP, but without TCP reliability and flow control. UDP is such a simple protocol that is usually described in terms of what it does not do compared to TCP. UDP features include the following: data is reconstructed in order that it receives. Any segments that are lost are not resent. There is no session establishment and the sending is not informed about resource availability. For more information on UDP, search the internet for the request for comments RFC. UDP header. UDP is a stateless protocol, meaning neither the client nor the server tracks the state of the communication session. If reliability is required when using UDP as a transport protocol, it must be handled by the application. One of the most important requirements for delivering live video and voice over the network is that the data continues to flow quickly. Live video in voice application can tolerate some data loss with minimal or not noticeable effect and are perfectly suited to UDP. The block of communication in UDP are called datagrams or segments. These datagrams are sent at best effort by the transport layer protocol. The UDP header is far simpler than the TCP header because it only has 4 fields and requires 8 bits, 64 bits. 8 bytes, 64 bits. The figures show the fields in a UDP header: source port, destination port, LAN, checksum, and application layer data size varies. UDP header fields. The table identifies the description and describes the 4 fields in a UDP header. The first is source port a 16-bit field used to identify the source application by port number. Destination port, a 16-bit field used to identify the destination application by port number. Len, a 16-bit field that indicates the length of the UDP datagram header, and checksum, a 16 field used to error checking of the datagram header and data. Applications that use UDP. There are three types of applications that are best suited for UDP: live video and multimedia application. This application can tolerate some data loss, but require little or no delay. Examples include both IP and live streaming video. Simple request and replay applications. Application with simple transition or transaction where a host send or request and may or might not receive a replay. Example include DNS and DHCP, domain name system or service, and dynamic host configuration protocol. And application that handle reliability themselves. Unidirectional communication where flow control, error detection, acknowledgement, and error recovery is not required or can be handled by the application. Examples include SMTP and TFTP. The figure identify the application that require UDP. DHCP, DNS, SNMP, TP, TFTP, VoIP video conferencing. Although DNS and SNMP use UDP by default, but can also use TCP, DNS will use TCP if the DNS request or DNS response is more than 512 bytes. Such as when a DNS response includes many name resolutions. Similar, under some situations, the network administrator may want to configure SNMP to use TCP. And question 1. Which of the following is a stateless best effort delivery transport layer protocol UDP? Which UDP header statement is true? For fields in a bytes header. Which two applications will use the UDP transport layer protocol? Choose two. Okay. TFTP and VoIP. Which two fields are the same in the TCP and UDP header? Choose two. Destination port number and source port number. Okay. The key in this chapter is port numbers. Multiple separate communications. As you have learned, there are some situations in which TCP is the right protocol for the job, and other situations in which UDP should be used, no matter what type of data is being transported. Both TCP and UDP use port numbers. The TCP and UDP transport layer protocol use port numbers to manage multiple simultaneous conversations. As shown in the figure, the TCP and UDP header fields identify a source and destination application port number. The source port number is associated with the originate application on the local host, whereas the destination port number is associated with the destination application on the remote host. For instance, assume a host is initiate a web page request from a web server. When the host initiates the web page request, the source number is dynamically generated by the host to uniquely identify the conversation. Each request generated by a host will use a different dynamic create source port number. This process allows multiple conversations to occur simultaneously. In the request, the destination port number is what identifies the type of the service being requested of the destination web server. For example, when a client specific port 80 in the destination port, the server that receives the message knows that web server are being requested. A server can offer more than one service simultaneously, such as web service on port 80 while it offers file transfer protocol (FTP) connection establishment on port 21. Socket pairs. The source and destination port are placed within the segment. The segments are then encapsulated within an IP packet. The IP packet contains the IP address of the source and destination. The combination of the source IP address and source port number, or the destination IP address and destination port number, is known as a socket. In this example in the figure, the PCP is simultaneously requesting FTP, file transfer protocol, and web service from the destination server. Okay, FTP connection and web connection. This is the socket of FTP connection, source port 3005 and the port 21. And the web connection socket is source port 1099 and destination port 80. Source destination, okay, in the same time. This occur in the same time. In this example, the FTP requests generated by the PCP for the PC include the layer 2 MAC address and the layer 3 IP address. The request also identifies the source port number 3005, dynamically generated by the host, and destination port. Identify the FTP service on the port 21. The host also has requested a web page from the server using the same layer 2, layer 3 address. However, it's using the source port number 1099, dynamically generated by the host, and destination port identify the web service on port 80. The socket is used to identify the server and service being requested by the client. A client socket might look like this 1099 representing the source port number 192.178.1.5 and double colon 1099. The socket on a web server might be 192.178.1.7 double colon 80. Together, these two sockets combine to form a socket pair. Okay, socket enable multiple processes running on a client to distinguish themselves from each other and multiple connections to a server process to be distinguished from each other. The source port number acts as a return address for the requesting application. The transport layer keeps track of this port and the application that initiates the request so that when a response is returned, it can be forwarded to a correct application. Port number groups. The Internet Assigned Number Authority (IANA) is the standard organization responsible for assigning various addressing standards, including the 16 bits port numbers. The 16-bit used to identify the source and destination port numbers provide a range of ports from 0 through 65,535. The IANA has divided the range of numbers into the following three port groups: well-known ports 0 to 1, 0 to 1023. These port numbers are reserved for common or popular service and applications such as web browsers, email clients, and remote access clients. Define well-known port to common server application enable clients to easily identify the associated service request. The next group is registered ports from 1024 to 49,000. 151. These port numbers are assigned by YANA to a requesting entity to use with the specific process or application. These processes are primary individual applications that I choose to install rather than common applications that will receive a well-known port number. For example, Cisco has registered port 1812 for its radio server authentication process. And the last group is private and or dynamic ports. Is from 49,152 to 65,535. These ports are also known as ephemeral ports. The client operating system usually assigns port numbers dynamically when a connection to a service is initiated. The dynamic port is then used to identify the client application during communication. Note: some client operation systems may use registered ports instead of dynamic ports number for assigning source port. The table displays some common well-known ports number and their associated application. Port 21 TCP File Transfer Protocol, 21 TCP File Transfer Protocol Control, 22 TCP Security Shell, 23 TCP Telnet, 25 TCP Simple Mail Transfer Protocol (SMTP), 53 UDP TCP Domain Name Service, 67 UDP Dynamic Host Configuration Protocol, 68 UDP Dynamic Host Configuration Protocol Client, 69 UDP Trivial File Transfer Protocol (TFTP), 80 Transfer TCP Hypertext Transfer Protocol, 110 TCP Post Office Protocol version 3 POP3, 143 TCP Internet Message Access Protocol IMAP, 161 UDP Simple Network Management Protocol SNMP, and 443 TCP Hypertext Transfer Protocol Secure. Some applications may use both TCP and UDP. For example, DNS use UDP when clients send requests to a DNS server. However, communication between two DNS servers always use TCP. Search the YANA website for port registry to view the full list of port numbers and associated applications. The netstat command: unexplained TCP connection can pose a major security threat. They can indicate that something or someone is connected to the local host. Sometimes it's necessary to know which active TCP port connections are open and running on a network host. Netstat is an important network utility that can be used to verify those connections. As shown below, enter the command netstat to list the protocol in use, the local address and port numbers, the foreign address and port numbers, and the connection state. Okay, netstat in the terminal: protocol, local address, foreign address in the state. By default, the netstat command will attempt to resolve IP address to domain name and port numbers to well-known application. The The "-n" option can be used to display IP addresses and port numbers in their numerical form. And question 1. Assume a host with IP address wants to request web service from a server. Which of the following will display the correct socket pair? Okay, a web service. Okay. Which port group include port numbers for FTP, HTTP, and TFTP application registered ports? Sorry, is well no ports. My bad. Which window command will display the protocol in use, the local address and port numbers, the foreign address and port numbers, and the connection state netstat? Mhm.